Allow me to introduce our speaker for today's webinar, Donald Harper. Donald is a field application engineer with Amphenol Communication Solutions Business Unit, SSIO. He holds experience in connector design and new product development. Thank you for joining us today, Don.
Thank you for that introduction and welcome to everybody. We're going to be talking about our DDR applications and our connectors. And so Greta had already mentioned a little bit about me, so I don't want to talk too much about me, but my background has been as a development engineer. And through that, I've designed a bunch of different connectors. And now I have the privilege of going out and working with our tier one customers on our next generation stuff. So in terms of DDR, what we're going to see today is what is the future looking like for DDR? And maybe that's why you joined. And we're going to talk about that. What's going on in the standards? What does an application look like? And what do we offer for solutions? And as you probably know, because you joined this seminar, Amphenol is one of the world leaders in connectors, and we offer a broad range in every area. And certainly DDR is one of the main categories that goes into every server and applications that are being used out there. Especially right now, all the AI stuff is driving more and more DDR and faster DDR. That's what we're going to be talking about. There's so many acronyms that get thrown around here. It's even hard for me to remember all of them. So I just wanted to make some comments here about what does DDR stand for. And I put that on the screen here, just pulled out of Wikipedia. It is the double data rate. That is how this memory design got started out. And it was previously just called SDR RAM, or synchronous dynamic random access memory. That's kind of the history. There is a lot of history, and the DDR product was introduced in the year 2000 and started most of its implementation in 2002 and was primarily driven by Intel. And they're still one of the primary leaders. But it has expanded, and we're going to show you now what's going on in the DDR world. So we have people that cover all these standards, and so we're pretty active in all the standards, but especially DDR. We're looking right now to our customers and to the standards committees for defining what is DDR6 going to look like. And so we'll talk about that a little bit. DDR6 and both 5 are defined in this JEDEC standard, in a JEDEC standard. If you need more information on that, we can certainly give that to you. This is one of the oldest standards, or the longest implemented standards, and it just keeps getting faster. We extend the life by adding more and more signal integrity capability. And now we're so excited because there is a new form factor called CAM that's coming out, and I'll tell you a little bit more about that. And as you can see on this slide, the DDR, traditional DDR, is on the left-hand side, and we have a new memory connector that's being implemented right here, as you can see on the right-hand side, called CAM, and it is a compression attached memory module. We'll talk a little bit more about all this. It's super exciting. This is just a picture of a blade that is pulled out of a server. This is public. I think I might have found this just on the internet, but it represents what a typical DDR application looks like. And what you're seeing is these big heat sinks right in the middle, sitting over top of some kind of probably a processor in this case, maybe a switch, but something that's going to run and need lots of memory to do its function. So what designers do is they stack up as many of these DDR memory modules as close as possible to the processor so that the processor can interact with all this memory to do what it does. This seems especially important now in our AI world, where faster speeds and more memory is just the demand of the industry right now. I thought it might be interesting and helpful just to talk about where DDR kind of lays in terms of all the other card edge products. There's a couple other standards, as probably you guys know, for SSDs and for M.2. And this chart here shows from the right to the left, across the top, is the contact pitch for the connector. And what you can see as is the PCI connectors were one of the first ones to come out. They started out with a 1 millimeter contact pitch. And then DDR came along and they wanted to improve the density, so they made it a little bit tighter pitch. But the evolution of the card edge has continued on through continually getting smaller and smaller pitches. And we offer these products, we call our product, our card edge product family, the Cool Edge product family. And we'd love to talk more about that. But in terms of DDR, right now we're sitting on all of our DDR4, DDR5 is all selling. The most common version of that is a vertical orientation. And I'm going to love to show you all the different things that we have for DDRs. What drives these DDR connectors is all these chips that come out, the processors that come out from Intel, AMD, NVIDIA. They all need memory, and they turn to the standards and to us as connector companies to be able to give them this DDR form factor in any different orientations, as well as different speeds. And we have Gen 5 out. You'll see that, and I'm going to show you what's coming on for Gen 6 as well. So there are other form factors for memory that are in this space. CXL is one of them, and it is somewhat like a DDR. It's a card edge, as you can see on the right-hand side. And so we have different formats as well as the DDR. But the interesting and the amazing thing that's new and coming out, and this has been in development for quite some time, is a CAM connector. And that's going to be a next generation for many reasons. And we'll talk about those in a little while. I threw in another picture just to show you some DDR cards sticking in slots. You can see them just right next to a processor there on this blade server. And this is a very typical application, and it's what you find in every server. So you've joined to learn about our DDR, probably not because there's something that you don't know, but wanting to find out what is Amphenol doing and what does the future look like. So that's where we're kind of headed with this. What does Amphenol offer for DDR5? Well, we offer everything. As you can see, we have 4 different part numbers there of the standard sizes. And all of these are going to be surface mount designs running at 32 gigabits per second. And as you can see down at the bottom here, the Amphenol design has taken a lot of design details to make our connector more robust. The challenge for these is pressing in this card and then ejecting it if it needs to be removed. And so there's a lot of forces associated with that, and we have reinforced our connectors to be able to handle multiple insertions and without breaking. There is a new version of DDR5 that's coming out, and it's just a 287 position. These standards, for different reasons, want to have unique designs for different platforms. This is kind of one of them. This is a unique design for one of the Intel chips, the Birch Stream platform. And all it literally is, so don't get too confused by these things. All it is removing one pin so that this makes it a unique design, and it provides other things, benefits for our customers as well. But there's a bunch of different variations, as you can see, but all of them are just form factors for the memory modules, and we offer these new ones as well. DDR5 also comes in a registered and an unregistered format, which is just another standard, not to get confused by all the acronyms that are thrown around. This is primarily helping the systems guy know what memory cards go in these sockets are specific to some functions in the registered or an unregistered application. One of the things that is developing right now is the need for faster and more memory. So there's currently in the works a tall version. It doesn't have too much of an impact on the connector, but as you can see, the card is getting a lot higher. So there's some mechanical issues that need addressed, but the connector is pretty much the same connector, and you may see this coming out more and more as our customers need more and more memory as close as possible to the processors. One of the other ways that we try to accomplish this is we have a design, and this is in a concept form only, for any customer that would like to try and keep their DDR into the lowest rack space as possible. This is actually designed for 1 year, and it is an angled version of a DDR, so that if you had a limited height requirements, we have a design that would give you a special situation for an angled DDR connector. Another special version, and these are typically driven by customers and their needs, is we do offer our DDR in a single latch solution, meaning typically the DDR has latches on either side. In this design, we've just fixed one of the ends and only have a latch on the other end. Nothing too unique. The connector's all the same. What you can see is Amphenol works with our customers to provide all these different applications. And right now, what we're doing, we're working with our customers in our pathfinding effort for our DDR6. So there is two ways that we are looking at this, and that you should look at it, is there is the evolutionary path that is going forward, and that's taking kind of the same card edge connector and just evolving it into higher pins, a tighter pitch, and trying to the main effort here is to get more pin counts and run at faster speeds. That's the evolutionary track. The thing that's going on right now, and it started maybe a year and a half ago, is there's a revolutionary new design that's coming out called CAM. And I'll talk in a little bit more about this, but it's a compression compact form factor. You can see that gray kind of strip there on the other side. That is a piece of plastic with like 644 contacts in it. And the way it gets designed is shown there in kind of a stack up. This allows designers to get these things extremely close to the processors and offer a lot additional memory. I'll show you a little bit more about CAM2 and what it looks like. This is kind of just the overview slide. It's going to have better SI performance, and it's really going to shine in a laptop or something that is more of a mobile device that needs this high kind of performance. You'll be seeing a lot more of CAM2. I'm working with customers right now on implementing their designs. The CAM is originally a standard that was developed by Dell with Amphenol through a standard, the JetX standard, and now it's getting rolled out into newer applications. Here's the original design, and as you can see in the left-hand picture, what this does is provide a compressive contact between the main board up to a memory card. And as you can see, that memory card lays parallel to the board, so it takes up a lot of space in that direction, but it allows for much more memory and faster memory, and this is why this is catching on and become so important. Here's a couple applications to show you. These are in the field right now. This is just things you can find on the internet. Customers that are implementing this in laptops and in some servers. This is DDR5 CAM. And there is, just so you don't get too confused, CAM is evolving. There was a CAM, then there was a CAM1, now there's a CAM2. It's offered in different heights and different pitches, and Amphenol is actually leading the development, and so we have these available, and they will be showing up in a lot of our customers' designs, and I expect you'll be needing them and wanting them as well. As I'm wrapping down in the DDR section, there is another application that's pretty unique, but it's not a general application. We do offer a high mating test type of a socket for DDR. We have it in the DDR5 speeds. And what this allows a customer to do is use a compression interface on their main test unit. And it provides a high durability contact that can do over 100,000 cycles. And then once that thing wears out or there's any issues, it can be unscrewed, lifted right off the board, and the test equipment allows the connector to get replaced. This is, as you can imagine, extremely helpful for somebody who makes the memory and has to do some levels of checking through their process. So we offer that, and we are selling this mostly to the DDR manufacturers. The final thing to comment on is Amphenol has a dedicated section of our website that is represents all of our DDR4 and 5, and we'll be keeping everybody updated on what's happening with DDR6. But here you could get any of our products. You could get some drawings on the CAM products, and I want to encourage you to contact Amphenol. We do have the best in class application people, support people, and we have a broad portfolio of all these products. So if you're looking for DDR, we have currently a portfolio to cover everything being currently done at Gen 4 and Gen 5, and we're going to be a leader in Gen 6. However that looks like, and I think it's likely going to be two solutions. There will still be the traditional DDR form factor in a vertical, and there will be this new CAM connector. So I want to say thank you for joining, and we're going to open this up. I'll turn it back over to Greta.
Hi, Don. Thank you. We will now open our Q&A session if anyone has any questions for Don. And Don, I do have a question for you already. Does Amphenol have a high durability DDR connector for test applications?
Well, that probably just came in before I got to the slide, so that's great to know. Yes, we do. I probably should have put the part number on this. But what I do know is you can go to our website, and all the information on the high durability DDR connector is represented right there. But this is what it looks like. Would you have any other specific questions that you might be wondering? How does it work? What does it look like? And hopefully this slide can answer your questions.
Thank you, Don. And what is the contact pitch for DDR connectors? Is there a standard?
Yes, there is. And I knew I flew through all these slides so quickly. So let me just go back to a slide that can show that. This slide shows our whole Cool-Edge product family, and I have the DDR kind of shown there. It is at 0.85 contact pitch, and that's maybe one of the limiting factors of how long this thing can get. So right now we're at 287, 88 contacts. We could go a little bit longer, but it's reaching its limit on how long this can get. And that's why there's new form factors being discussed, because we know the industry is demanding more contacts and faster speeds. And so that's what Amphenol does the best.
Thank you, Don. And I know you talked a lot about the CAM2, which is SSIO's revolutionary new form factor coming out for memory applications. Could you tell us a bit more of what we should be anticipating?
So the question was about CAM2, but I wasn't sure I got the last part.
Yeah, like what should we anticipate, and do you know when this should be arriving for everyone?
Oh, okay, yes. Well, we have manufacturing capability for production right now,
Mhm.
and we are supplying maybe not high volume, but certainly in volume product to our partners, and they have in test and in design many applications. It's helping the demand certainly for low profile applications like a laptop. It fits perfectly, but it is going to roll into servers as well, and we're working with customers to do that. So I guess my answer is it's available right now. There are part numbers. They're limited in how many stack heights are available. I think we might only have two, but they're primarily, the standards are going to focus down on probably two things. One that is the lowest profile, and that might be 1 millimeter. And then there's some other stack heights that aren't so critical that are going to be at a higher stack height that helps with other things, molding a housing and things like that.
Great, thank you, Don. And that looks like that is all that we have for you today. Thank you, Don, and thank you to everyone for joining us. We hope you enjoyed today's presentation with Donald Harper from our SSIO business unit. Have a great rest of your day. And
Thanks,
again,
Greta.
yeah, thank you, Don.